Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Fischer esterification converts a carboxylic acid to an ester using an alcohol in the presence of an acid catalyst, H2SO4, with heat. The reaction is R2 plus CH3OH- CH3 plus H2O. Moving on to the next step. Identify the starting material. The starting material is terephthalic acid, benzene 1,4-dicarboxylic acid, which has two CO2H groups at the para positions of the benzene ring. Moving on to the next step. Identify the reagents. Two equivalents of methanol, to CH3O, are used with H2SO4 as acid catalyst and heat, delta. And for the final step, determine the reaction outcome. With two equivalents of methanol and acid catalyst, both carboxylic acid groups undergo esterification. Each CO2H group reacts with one CH3O to form CO2CH3. This converts both acid groups to methyl ester groups, giving dimethyl terephthalate, a benzene ring with CO2CH3 at both para positions. Option A shows one CO2CH3 and one CO2H monoester. This would be the product if only one equivalent of methanol were used. Incorrect. Option B shows CO2CH3 at both para positions, 1,4-dimethyl terephthalate. This is the correct product of esterifying both acid groups. Correct. Option C shows CO2CH3 at meta positions, 1,3 substitution pattern. The starting material is para-substituted, so this regiochemistry is impossible. Incorrect. Option D shows C is equal to O, CH3, acetyl ketone groups at para positions. Methanol does not convert CO to a methyl ketone that would require a different reagent. Incorrect. With two equivalents of methanol provided and acid-catalyzed conditions, both CO groups are fully esterified to give dimethyl terephthalate, which matches option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.